So we know that it told us what the original rational expression factors to, or at least in the denominator. So that made it nice. We have to deal with that cubic equation. And then because we know that the first factor is a linear factor, ax plus b, or mx plus b, and this is an irreducible quadratic. In other words, we can't factor x squared plus 9. If it's x squared minus 9 would have been set, but difference two squares, but this isn't factor, so we're done with that. We can't factor it. So for the linear factor, we just stick a constant on top. For the non-irreducible quadratic, the degree of the numerator is always one less than the degree of the denominator, right? So see, that's 0. X at a times x to the 0, well, that's one less than x to the first. Okay, so same thing here. So now we just got to clear the denominators by multiplying everything by that x plus 2 times x squared plus 9. So the part on the left clears everything, so we just have the 7x squared plus 5x plus 34 equals, so then if we're going to multiply this by x plus 2 times x squared plus 9, and that's getting distributed to that one, see how the x squared cancels out, or the x plus minus x plus 2 cancels out. So that leaves me a times x squared plus 9. And then for the second part, bx plus c is the numerator. That's going to get multiplied by the x plus 2 because the x squared plus 9 factors out. So then just doing a little more algebra, so we know that ax squared plus 9a has to equal, and just going to do some foiling here. So what is that? Bx squared 2b plus c, so plus 2bx plus cx plus 2c. I don't know where I wrote equals here. They should have a plus. And that has to equal this other thing. So then what we can do is begin to set up the matrices. Ax squared plus bx squared, there's no other squared terms. That has to be equal to 7x squared. And then the x terms, what do I have? I have a 2bx plus a cx. That has to be equal to 5x. And then constant terms, I think 9a plus 2c, that has to be equal to 34. So then if we set up the matrices here, just a minute, and not that we need matrices, but I think they make it easier. So I see, well, let's do the intermediate steps in case people are a little lost. So I know that a plus b has to be equal to 7. I know that 2 plus 1 has to be equal to 5. See how I'm forgetting all about the b and the c? I'm just kind of using the coefficients to write them. And then 9, oh, I'm sorry, 2b plus 1c. And then 9a plus 2c has to be equal to 34. So then we write the matrices 1, 1, and 0 because there's no c in that term. No a in this next one, so 0, 2, and 1. Then we've got 9 0 b's and 2 c's. That's going to be multiplied by ABC. And then the constant terms are what? 7, 5, and 34. Now we just throw this in the calculator, do A inverse times B, and that should give us the answer. My calculator told me that I'm getting 4, 3, -1 for a solution. So that means, let's see, the constant term A was over the x plus 2. So 4 over x plus 2. And then I get the quadratic term, so 3x minus 1 over x squared plus 9. And those should be the right answers. And we could always check. I guess you should check maybe. If I put those two fractions together, I should get that original left-hand fraction. So 4 times x squared plus 9 plus 3x minus 1 times x plus 2, and that's all over that LCD. So what am I getting? I'm getting I thought I paused it. Let's see, I'm getting, let's see, it's still recording? Yeah. So I'm getting 4x squared plus 36 plus, let's see, I gotta FOIL this other part, so I'm getting 3x squared, let's see, 6x minus 1x is plus 5x minus 2. Now let's put everything together. Let's see, I get 7x squared plus 5x plus 34, and I think that's what I'm seeing up here, right? Isn't that what I'm seeing here? That's what I'm seeing here, and that's all over the LCD. So yeah, I did that correctly. Okay, so hopefully that helps you do these ones with have those extra terms.